Okay, let's look at 2.2, which is about separable equations. So a first order differential equation of the form dy dx equals some function of x multiplied by some function of y is said to be separable. So let's look at an example. So example here, say dy dx equals x squared times y to the fourth plus 2y squared plus 1. This to be separable because this guy here would be your g. And this right here would be your h of y. This would be your g of x. Let's look at an example of something that's not separable. Okay, well here's a simple example here, say dy dx equals x plus y. This is not separable because you cannot write this as a function of x multiplied by a function of y. You can keep a plus sign here. So this would not be separable. Okay, so it's not separable. Alright, let's keep moving on now. So we're going to look at how we can actually solve a separable differential equation. So let's make some observations. So we're going to assume that, say, h of y is not 0 for this analysis. So suppose we have a separable differential equation here. Let's divide both sides by h. So doing that we get this then. 1 over h dy dx equals g of x. Now we're going to, say, integrate both sides with respect to x. Okay, so integrate both sides. This means with respect to x. So doing that we get then this. So the integral of 1 over h of y dy dx equals integral g of x dx. Okay? So next. Okay, let's recall by the FTC, which is the fundamental theorem of calculus, that the integral of, say, big F prime of y dy dx, integral with respect to x, will be big F of y plus some constant. And the reason for that is if you took the derivative of big F with respect to x, using chain rule, it's going to be the derivative of big F times dy dx, which is this guy. So showing that big F of y is the antiderivative of this guy. Alright, so this implies then the integral of f prime of y dy dx with respect to x. You can think of the dx's as cancelling, and it will equal just the integral of f prime of y dy. So I can apply that same reasoning now to up here. So you can think of those dx's as cancelling right here. Okay, so now let's look at an example how we can use this to solve a differential equation. So let's look at an example. I'm going to write some stuff here now. Okay, so let's look at an example. It says solve the initial value problem. So we have dy dx equals 2 times y minus 3 over x, with y of 1 being 2. So this is separable. So another way you can think of separable is you can get all the x's and dx's on one side and all the y's and dy's on the other side. So let's first multiply, say, both sides by dx here. So multiplying by dx we get then, so we get this, so it'll be dy equals 2 times y minus 3 over x dx. Now I want to get all the x's on one side, all the y's on the other side, so let's divide both sides by 2y minus 3. So let's do that. So dividing both sides by 2y minus 3, we get this then. Now let's integrate both sides. So integrating both sides, we get this then. So the integral of 1 over x will be ln. This guy we're going to make a u substitution here. So we're going to let u equal y minus 3. So I'm letting u equal y minus 3. So then du dy will be 1. So du will equal dy. So let's make the substitution over here then. So making the substitution, we get then, look at this, so I pull the 1/2 out front of the integral, so it'd be integral of 1 over u du equals integral of 1 over x dx. So it's going to be ln of u here, it's going to be ln of x. So let me write it over here. So we get this then, 1/2 ln of u equals ln of x. I'm putting the constant on this side. I guess it should be constant on both of these, but I can move around and just have one constant here. So the constant's over here. Now let's replace the u with y minus 3 and bring up the, actually we can bring up the 1/2, say, on the exponent here. Let's do that. Okay, so bring up the 1/2. Then replacing the u now with y minus 3. Let me do that. We get then, so we get this. And now let's get rid of the ln's by doing exponentiating both sides with base e to get rid of the ln. So doing that, we get then, we get this, and then these will cancel. Let me simplify this a bit further now. So I get this then. So this will become x here. I'm going to let e to the c. I'm going to call that as c1. So we get this, y minus 3 to 1/2 equals c1x. Let's square both sides then. So doing that, we get, so we get then y minus 3 equals c1 squared x squared. I'm going to call c2 c1 squared just for ease of notation. I'm out of space here, so let me erase some things up here and we'll continue. Okay, so like that. Okay, so we then have y minus 3 equals c2 x squared. We can then solve for y by adding 3 to both sides. So let's do that. Okay, so we have y equals c2 x squared plus 3. Now we need to satisfy our initial condition, so we need to, that's going to impose restrictions on c2. So let's see what happens when you put 1 in place of x. So putting 1 in place of x here, we'll have then c2 times 1 squared plus 3. That needs to equal 2. So you basically have c2 plus 3 equals 2. So subtracting 3 on both sides, looks like c2 is going to be minus 1. So c2 is minus 1, so therefore our final answer then, so hence our final answer will be y equals negative x squared plus 3. Okay, so hence that's our answer. We can now check to make sure we got it correct, because this should satisfy this differential equation up here. So let's check our answer. So we're checking to see if our solution is indeed a solution. So let's first find the derivative of this guy. So derivative would be negative 2x. Let's note that here. So again, note y prime is negative 2x. Bring it down the 2, subtract 1. So I'm going to put that in place of dy dx here. And in place of y, I'm going to put negative x squared plus 3. So let's do that. Okay, so making a substitution. So put a negative 2x in place of dy dx here. And in place of y right here, putting negative x squared plus 3. So doing that over here, the 3's cancel. And then we end up with here, we end up with then negative 2x equals 2 times negative x squared over x. And that's just going to be negative 2x equals negative 2x, so it checks out. So we've shown it's a solution. Okay, so therefore our solution is y equals negative x squared plus 3. Okay, so we're done with the question. And we're done with the section also, so I'm going to leave the video here. We'll do some more examples in a different video. So let's leave it there.